Okay, so for this problem, what I'm seeing is I'm seeing that they're telling me, let's see, the average number of weeks an individual is unemployed is 31 weeks, and then assume the population for all unemployed individuals and the mean length is 31 weeks, and the population standard deviation is 3 weeks. So it told me a mean and the standard deviation and a sample size. So I've got a sampling distribution situation going on here. So for the very first one here, they talk about a single random sample, a single, whereas versus now this is a sample size. So this is the sampling distribution. This is just a single individual. So for the single individual, notice I'm looking for the probability of getting a value less than 32. So I'm going to come over here. My sample mean is 31. And we know the standard deviation for the population is 3. And I want to know less than 32 weeks. So I'm going to go below 32 weeks. And I get that average, or not that average, but I get that 0.63. And what are they telling me? There's that answer. Okay, so that when it's a single person, we don't have to do anything with the population standard deviation. Now we're into a sampling distribution situation where we get those piles of X bars accumulating. And in this case, we got to get the standard deviation for all these sample means. Standard error is another name for it. So the standard deviation for the population is 3. And I'm divide that by the square root of 31. And if I do this, let me do it out of my calculator here on the screen. So 3 divided by the square root of 31 is 0.53882. So I'm going to come over here for the standard deviation. Same sample mean, right? 358. I mean, same population mean, because the mean of all those, let's see, I'm going to have to round that to 6, I think. Shouldn't matter. And then it's below 32 here, and I'm getting that. What are they saying is the answer? That number, okay? Samples will vary less than the individuals will, and that's why we have a smaller standard deviations. And that'll come important next week when we look at hypothesis testing. Okay, so hope that helps you answer this question. If you're going to use your calculator for it, again, it's just normal CDF. And you're going to say, what's the low? Well, the low is like negative 1,000. Do something ridiculously low. I mean, you could probably do 0 and get away with that. And then the upper value is 32. For the first question, when it's a single individual, the mean was 31, right? And the standard deviation was 3. Notice I got the answer. And then the only thing that changes is the standard deviation. And what's nice about the graphing calculator is that old population standard deviation was 3. I'm just going to divide that by the square root of 31 right here. And I don't have to worry about writing in that 0.5 thing. It'll automatically take care of it. And notice there's that number. Okay, so I hope that helps you do this question.